Okay, so today I'm going to go over problem number 9 from the exam. So what we have is a particle traveling through this potential and being injected into this magnetic field here with charge Q1, mass M1, and radius 1.2. And we want to see what happens to a particle with twice the charge and 1/3 the mass. So we know that the potential energy here is going to be equal to kinetic energy here. So we can equate U and K here, which is Q times the potential and 1/2 mv squared. And when we equate those two and solve for V, we get V equals the square root of 2Q times the potential over M. And we can get the radius from the force equation, so we know that F equals ma, which for a particle traveling in a circle is mv squared over r. And we know that the force due to the magnetic field is qv cross b, which is qv sine theta, but in this case our v and b vectors are always perpendicular, so we're going to get qvb. And we can solve for r here, and we get mv over qb. And we can divide r2 by r1. And when we do that, this b here is going to cancel because it's constant. And then in the v, this 2 and this potential is going to cancel. So what we're left with is just dividing r2 by r1, we get m2 times the square root of q2 over m2 all over q2, which we just plugged in from these relations here. Over m1 times the square root of q1 over m1 all over q1. And we can see that the m1s and the q1s are all going to cancel here. What we're left with is 1 over 3 over 2, which is just 1 over 6, times the square root of 2 over 1 over 3, which is just square root of 6, which is about 0.408. So we can multiply that times r1 to find r2, and we get that r2 equals about 0.5. So the correct answer is C.